Hello, all. Welcome, everyone. My name is Raajesh, and I work as a senior data scientist in Infosys. I have 6 years experience in IT industry, and I have 4 years experience in machine learning and deep learning field. In this video, we will get a brief idea about the life cycle of a data scientist, what he or she will do, how he will approach the problem, and what is the work nature of them in the industry. The first step any data scientist is to understand the business. He or she has to talk to their respective customers or clients or stakeholders, whoever it may be, and understand what is the exact problem they are having and how we are going to solve that. Suppose if you are working for a client who like developing an app which is trying to predict these stocks, so you should understand that it is a regression problem and apply respective regression algorithms to solve that problem. Or for example, if you're working for some client who wants you to classify the reviews for the movie, so you have to understand that it is a classification problem and get the data of all the history of movies and the respective reviews and apply classification algorithms on top of it and complete the job. Or suppose if you're working for a retail customer and the client wants you to like they're ready to give the transactions of the customers in their area, and they wants you to cluster the customers based on their transactions. So you should understand that it is a unsupervised learning problem, and you have to respectively apply some clustering algorithms on top of it to solve that problem. For example, if you are working for a banking domain and if your client wants to classify the fraudulent transactions, then you have to understand it is an anomaly detection. For example, if you always do transactions of 10,000, 20,000, or 30,000 at max, suddenly if there is a transaction of some 2 lakhs, 3 lakhs, that is an anomaly. So in this way, you have to apply some anomaly detection respect algorithms and solve that problem. For example, if you're working for, let's assume you have some small two-tier company as a client, and they building some application, education related application, and they wants to give the recommendations based on the students education history, then you have to apply some recommendation based algorithms. So this is the first step any data scientist approach, like by understanding the users or clients problems and get the picture of how we can like approach this by using which algorithms like that. And there are four steps which will be involved, like data mining, which is for extracting the data, and then we have data cleaning, which is to remove the unwanted data which doesn't add any good information for the model. And we have something called data exploration. For that we have tools like Power BI and Tableau to visualize the data. And we have another concept called as future engineering, where we completely understand the data and start building the new futures automatically. So for all these four steps, I am going to explain with the three scenarios which we will easily understand. Let's take the first scenario. We all know about the Titanic ship that crash movie and that problem we know, right? So suppose you have all those data. How, as a data scientist, you are going to understand about, like, get the insights about the data? So the first thing is like you have to like go through all the futures available in the data set. For example, for this Titanic problem, you will get the data like the people who travel, like their ages and their like whether they are doctors or engineers or who traveled, whether married or not, or they whether they traveled with the childrens or siblings or parents, something like that. So you will get all these data. So as a data scientist, you can use Python libraries like Matplotlib, Seaborn, or Plotly to visualize the data. Like I'll give you an example. So with this libraries, you can visualize the data in such a way that for every class, for example, people might have traveled in class 1 or class B or class C. So in each class, how many traveled, in that how many males survived and how many females survived. So you can get collect the information about the data using Python libraries like Seaborn. Or you like simple Excel sheets, pivots also you can use and get to know about the data. Or if you have knowledge on business intelligence tools like Power BI or Tableau. From that also you can get the insights about the data. And then data cleaning, if you say, you can remove the unwanted columns. Like suppose we have in that we have like something called ticket number might we have in the Titanic problem, so that doesn't add any information to the model, so we can remove all those information from the data set. Or if there is a missing values, let's assume we have some missing values in the age, you can fill those with average, that we can do. Or you can go in depth and calculate the average values for males in that particular class, and then you can respectively fill that missing values. That also you can do. And future engineering, let's assume, so you completely understood the data, and you can think of creating a new future, like the person, whether he is traveled alone or not, whether he traveled with their parents or siblings, or whether he traveled alone or not. From this you can get to know, if the person is traveling alone, then there is a large possibility of surviving. But if he is traveling with his children's or parents, then there is less possibility of getting survived. So these are the common insights which we can apply when we get the use scenario like Titanic ship problem. Or for example, or then we'll take the next scenario, like suppose if you are working for a charity, and the team approaching you saying that we are running this charity for so and so long, we are approaching all the people in this particular area, but we are not getting the enough funds so that we can help our children who are like struggling to study. So they are coming to you and giving you the collected data set and asking you whom is the best to approach. Like if you approach this person, we have the large possibility of getting the fund from that person. So in this case also, as a data scientist, you should first explore the data. Like when you get the data set, you can understand what is the age range, or whether what is the education of each person which in the data set, whether it's a undergraduate or postgraduate, what is the total gain they are getting, what is the loss, what is how many hours per week they will work, occupation, marital status, like these are the things will be there in the data set, and you can understand that. And then as a data scientist, you should be very sure that you should not be like the data should not be skewed. So for that we will apply something called logistic transformation to get rid of the skewed data. Then there is a concept called one hot encoding, which will apply to discrete values in any columns of the data set. For example, if you have the column country, and if you have the values like India, France, England, you can convert, because anyway machine understands only number, so you can convert that text data with the help of one hot encoding into numbers. So these are the and then you can normalize also. That also you can do. There's a concept called min max scaler, which is one kind of normalization which you can apply if your data is like not properly in a range. So these are the things we will apply and solve these problems as a data scientist. Okay. I just want to tell that the more you clean the data and the data is more pure, so that your next part, the next guy who is very good in machine learning model, and they can easily apply on top of a data set and get a good result. So as a data scientist, you should first take care of cleaning the data or giving the proper data to the for the machine learning models. And then let's assume we will also take like we discussed, let's assume we are working for some retail store based client, and if they want you to cluster the customers based on their transactions. So in this thing like we discussed earlier, we'll apply all those things also. One main thing we need to consider here is to get rid of the outliers. What is outliers? So if you have some patterns for the customer, if one customer alone has some like some other in not in the correct range, if he some other space, if he is alone like anomaly kind of, so not in like if he is behaving weirdly, something it is called as anomaly or outlier, which adds impurity to the data set. So we have to avoid that outliers in our data set. So for that, as a data scientist, we will use methods like Turkey's method to avoid. We'll calculate the percentile, and we will calculate the probability of a data being in that range. If it is not in that probability, we will consider it as an outlier, and we will remove that from the data set. And then there is a concept we will use in order to reduce the dimensions of the data. which is called PCA, Principal Component Analysis, is to reduce the dimensions of the data. So these are the things as a data scientist you have to, these are the samples which I give. So as a data scientist, you should know how to work with data, how to transform your data, like future transformation, future engineering, data cleaning, all these things you have to do, as this is the first broad class steps you need to do as a data scientist. Then comes, once your data is ready, then comes the hero, machine learning. So then you have, in just to tell, in my previous video I gave the brief introduction about the machine learning, so you can go watch this video and get to know more about the machine learning. So in this data science life cycle, so we have our data cleaned, and the next step is the applying machine learning model. So for that we have many models: supervised learning model, unsupervised learning model, and reinforcement learning model. So which is supervised in the sense we have label, unsupervised is for clustering problem, and reinforcement is for games. So this is the next step for a data scientist, like applying machine learning algorithms. Please watch my previous video for more information about machine learning introduction I gave in the previous video. And then deep learning. This is the step, like what is data science comes first, and then machine learning. Deep learning, why? In the sense, if you want to, if you are working with images and if you want to complicate the architecture, that time we will go with deep learning. For images we have architectures like ResNet, AlexNet, and GoogleNet, all those architectures, and pre data sets like MNIST data, tiny ImageNet data, ImageNet data. So all these things we have in the deep learning. So this is the next step in the pipeline. So data science, cleaning the data using getting the data using ETL, then cleaning the data, and then applying algorithms using machine learning. Then for complicate algorithms, we'll go with complicate task, we'll go with the deep learning, and then reinforcement learning. So this is the path of a data scientist. So in deep learning, we have a concept called as convolution neural networks. So this is all about convoluting the image with the kernels, and like reducing the size of the image using max pooling. And if there is a concept called dropout, where we will use when there is a overfit. So I will discuss all about convolutions in my next upcoming videos. I will talk all this about in the computer vision. So in this video we'll get to know about the life cycle of a data scientist. So once if he finds he wants to apply deep learning algorithms, he will apply, take the respective architecture and the images and do all those cleaning, and he will apply on top of that. And then in artificial intelligence, where we'll always believe reinforcement learning is very close to artificial intelligence, where machines get to learn on by themselves. By for example, if you have the agent and if you ask it to play the chess game, and if it plays correctly you will give reward, if it plays wrongly you will penalize it. So that is what called as artificial intelligence in general. So that's how it goes. And then finally we can just see what are the typical three types of data analytics, which is descriptive analytics, diagnostic analytics, and predictive analysis. In this descriptive analysis we'll get to know what happened, and diagnostic why it happened, and the predictive is what is likely to happen, like applying some machine learning algorithms. So this is the overall life cycle of a data scientist. So in the this is the first video for introduction of data science, and in the next videos we will see the programming languages which data scientists preferably use, called Python, the Python basics and the concepts we will see in the upcoming videos. And I will slowly get into, like, learn all those machine learning algorithms. So I hope you guys liked the video. So please subscribe my channel and watch all the upcoming videos to get to know about the data science and machine learning. Thank you so much.